everyone, and welcome back. My name is Mr. Cobalt, and in this video we're going to go over how to find the OH minus concentration and the pH of basic solutions. So let's get into this. So this is very similar and analogous to what we did when we found the H plus concentration and the pH of your acidic solutions. So again, we can neglect the contribution of the OH minus by the autoionization of water, just like we could neglect or ignore the contribution of H plus or the hydronium ion from the autoionization of water as well. So ignoring that base, with the exception of if the base is very dilute, if the base is very dilute, then we may have to consider that. So all those conditions apply as well. So let's start with the strong base. So just like the strong acid, the strong base completely dissociates in water. So that means that the concentration of the base you start with is going to be equal to the concentration of the OH minus that you end up with in solution, because all of this is going to dissociate into OH minus and your positive ion, whatever that is. So once you know what the OH minus concentration is, like in this situation here, if I have 0.225 molar KOH, and that's going to completely dissociate into OH minus and K plus, then that means I'm going to have 0.225 molar OH minus in solution. So once I know the amount of OH minus I have and I know the concentration, now I have two ways of solving this problem. One way is I can take the equation that the Kw 1.0 times 10 to the negative 14 is equal to the H plus concentration multiplied by the OH minus concentration. I forgot my minus there. So these two multiplied together equals this. I know what my OH minus concentration is, so therefore I can plug that in here, solve for the OH minus, solve for the H plus concentration. So I find the H plus concentration, and then I can plug that into the negative log and find the pH. So then that should, there you go. That way it's less confusing. So the pH is equal to the negative log of the H plus concentration, so I can find the pH from there. A second method would be, since I know the OH minus concentration, I could plug that into the pOH equation. So I can find pOH by taking the negative log of the OH minus concentration. And then I can use this relationship that the pKw 14 is equal to pH plus the pOH. So now that I found pOH here, plug that in, solve for the pH. And so I should get the same answer. So that's how you would solve a strong base problem, to find the OH minus concentration and the pH of the basic solution. What if I have a weak base? So just like with a weak acid, we're going to ignore the contribution of OH minus by the autoionization of water. And just like with the weak acid problem, we're going to use an ice table, and we're going to treat this like an equilibrium problem, because it is an equilibrium problem. So in a weak base, not all of the base is going to take a hydrogen from water to form the pH. So very little of it is going to do that. So it's partially going to do this. So we're going to have to use this, solve this as an equilibrium problem, and use our ice table. So for example, here's my generic equation for a weak base. If I start with 0.1 or 1.0 molar of my base, I'm going to assume in the initial conditions, initially I have 0 BH plus and 0 OH minus. This is before any reaction takes place. And then I fill out my table just like I normally would. So here, I'm going to end up losing some of my base. So I'm going to make that a negative x. So whatever x is, that's the amount I'm losing. So I'm losing an x amount of base. Since it's a 1-to-1 ratio here, that means I'm going to gain a positive amount of my BH plus, same amount that I lost here, and I'm going to gain a positive X amount of my OH minus. And so when I find the equilibrium expression for the concentrations at equilibrium, then I just add these, the I row and the change row together, and I get 1.0 minus X here. 0 plus X is just X. 0 plus X is just X. And now I have my equilibrium expressions for the concentration of these species at equilibrium. I take the equilibrium expressions here and I plug them into my Kb, which is the base ionization constant. And so I take those values, plug them in here, and again, I'll get some sort of quadratic formula. So if I get, that'll be Kb. Let me write it up here. So I'll have Kb is equal to x squared. Since this is x and this is x, they get x squared. And then this is on the bottom, so B, the concentration of B is then 1.0 minus X. And now once I have this, and again, I'm going to have some sort of Kb expression here. So this reaction here with the base has a Kb. And so I'll know, I'll be given the Kb somehow. So then once I'm here, I can do the X is too small approximation, right? So I can get rid of X here and just solve for X using the simplified version. And then I want to double check to make sure that X is small approximation actually works and is valid. So I do the 5% rule. I make sure that it's less than 5%. If it's not, then I'll have to either solve it by the quadratic formula or I solve it by the method of successive approximations. So that's how I would solve the weak base problem. So again, this is very analogous, exactly pretty much the same as finding the H plus concentration and the pH of your basic solutions. So now once here, I forgot to mention that here, once I find X, I have to realize that X here is my OH minus concentration, not my H plus. So then once I find my OH concentration, once I find X, that's going to be my OH minus concentration. And then I go back up here to these two ways of solving that problem. I can plug OH in, solve for H plus, and then plug H plus concentration into the negative log to get the pH, or I can find the pOH of this and plug it into this equation and find the pH. So that's how you would find the pH of your OH minus concentration for a weak base. Thanks for joining me. I hope you enjoyed this video. If you did enjoy this video, hit that like button right here, right there, smash it, and subscribe to my channel. Let me know what you think down in the comment section. Hit that notification bell so you'll be notified about other videos I put out. In the section below, let me know what you think. Ask me questions. I'd love to hear from you. Thanks for joining me. Have a great day.